All right, in this one I'm just going to combine problems 1 and 2 from chapter 4, 4.3, problem 1. A 63 kilogram sprinter starts a race with an acceleration of 4.2 meters per second. What is the next net external force on him? This one's nice and easy. What are our variable? All right, we have a sprinter. He accelerates at 4.2 meters per second with a mass of 63 kilograms. We're looking for Fx. Okay, so sum of all the forces equals mass times acceleration. So we have our free body diagram, we have our correct equation, we have our variables, 63 kg, A equals 4.2 meters per second squared. We just plug them in, so this counts for the work. 63 kilograms times 4.2 meters per second squared, which gives us 264.6 newtons. So there's 1, 2, 3, 4, 5. 5 parts. All right, problem 2. If the sprinter from the previous problem accelerates at that rate for 20 meters and then maintains that velocity for the remainder of the 100-meter dash, what will be his time for the race? Okay, so let's draw out another free body diagram for this. We have our runner. He accelerates for 20 meters. So for the first 20 meters, we'll call that x1. He's accelerating. And then for the remaining 80 meters, x2, he doesn't have an acceleration, so he has a constant velocity. So for A1, we'll put 4.2 meters per second squared. A2 equals 0 meters per second squared. Okay, so that means in this part, our initial velocity, does he start from rest? Starts a race. Okay, so he starts from rest, so we know our V naught is equal to 0 meters per second. Let's write out our variables. A1 equals 4.2 meters per second squared. V naught equals 0 meters per second. X total equals 100 meters. X1 equals 20 meters. X2 equals 80 meters. Okay, what else do we have? All right, so what we want to find is the final velocity for the first 20 meters, right? So we're going to take all the x1 variables and find our final velocity. So we can use Vf squared equals V naught squared plus 2ax. So our initial velocity was 0, right? So Vf will equal the square root of 2ax, which will be the square root of 2 times 4.2 meters per second squared times 20 meters, which will give us 168 square root that 13 meters per second. There we go. That's our final velocity. So Vf1 equals, so we'll put a 1 there, equals 13 meters per second, which would make our V naught 2 13 meters per second. But he has 0 acceleration, so our Vf2 is also 13 meters per second. So what we have to do first is find the time for this section and then for this section. This one should be much easier than that section because we're just going to be using V average for that. So let's do that one first. So V average equals 13 meters per second, which equals x over t. And we know that x is 80 over t, so t will equal 80 meters over 13 meters per second, which gives us an time of 9.24 seconds. That is this for the second half, so this would be T2. All right, so let's do T1. We can use delta x equals v naught t plus 1/2 at squared. We have 20 meters equal to, our initial velocity was 0, 1/2 times 4.2 meters per second times t squared. So you would multiply that by 2, 40 divided by 4.2, you get 9.52 is equal to T1 squared, so T square root both equals 3.09 seconds. That's T1. So T total equals T1 plus T2, which would be 9.24 seconds plus 3.09 seconds, which gives you that was the total answer. This actually came out to 6.15. So this is 6.15. So the total time is 9.24 seconds. So when you run this math, you should get 6.15. I jumped the gun while I was reading over my notes. All right, so calculate the V average for the second half and use our kinematic formulas for the first half. So free body diagram, our variables, using the correct formulas, getting the correct answer. I would get -1 here because I messed up the arithmetic here, so +1. So I got 9 out of 10 on that. All right, damn it.